Very warm welcome to everyone to this webinar on remote sensors and technology for better electricity system planning. This webinar is hosted by the Energy and Economic Growth Programme, and it's a program funded by the UK Department for International Development, as it was formerly known, now the UK Foreign, Commonwealth and Development Office. It's a 5-year program looking at many facets of the energy system. And today, I'm delighted to welcome 3 leading experts on the topic of how remote sensors, satellite images, and technology may help achieve access to electricity, enhance reliability of power supply, and help understand the interplay with economic development. My name is Ben Kloos. I'm the Head of Research and Engagement for the EEG program, and I'm a Senior Consultant at Oxford Policy Management. From OPM's side, I'm joined by Simon Trace, who is the Program Director of the EEG Initiative, and Simon will help ensure that questions from you, the audience, are answered throughout this webinar. The panelists will be Dr. Noah Klugman, co-founder and CEO of Nline Incorporated, and researcher on an EEG project that is measuring electricity supply reliability across distribution networks using grid-watch sensors. Dr. June Lukuyu is the incoming assistant professor in electrical and computer engineering at the University of Washington, and she is a researcher on an EEG project on harvesting the synergies of satellite data, machine learning, and survey data for electrification planning in Ethiopia. Dr. Anand Sudarshan is the South Asia Director at the Energy Policy Institute at the University of Chicago. Anand uses satellite data on pollution and high-frequency electricity data as part of an energy insight that we had commissioned for the EEG program. And this assessed the impact of COVID on India's economy. Anand is also a researcher on an EEG project on the implementation of smart meters in Haryana, India. The hope is to keep this webinar as interactive as possible. So while you, the audience, aren't audible, please ask questions. And the way to do it is at the bottom of your screen, you will see a button that says Q&A. And there you can type in any questions you may have. You can also post any comments or reflections in the chat box. We will try and answer as many of those questions as possible. This webinar is being recorded and will be available through the EEG website after the event. So I will start off with an initial round of questions and then hopefully hand over to Simon for questions from the audience. But to start off with, Noah, both as part of your corporate work, but also your research, you advocate that data is key. It's key to improving the reach, reliability, and resilience of power grids. So what role do you actually see for remote sensors in this? And just for the benefit of everyone, what are grid watch sensors that are using as part of your EEG project?
Thanks, Ben. Yeah, so hello, everyone. My name is Noah Klugman. I have been working on an EEG project now with the GridWatch project for 3-4 years at least. And just thank you just up front to EEG for supporting that work, and then also for inviting us all together to talk about data and reliability today. I actually just got back from the SE for All forum in Rwanda, and was really looking for lots of conversations about data and how that could tie into sort of the broader goals of resiliency. And I found some, but definitely have identified the need for more. So I think that this is an awesome effort to start that conversation again up. So Nline started from my PhD research in electrical engineering at UC Berkeley, where I was advised by Eric Burr and Prabal Dutta. And has sort of grown. We're a 10-person company now. We've got employees in 4 different countries. And we have a technology that is small. I broke my rule, and normally I'm traveling right now. Normally I always have one with me so I don't have to just show an empty hand, but they're about the size of a deck of cards, maybe a little bit bigger. They plug into outlets. They're pretty inexpensive. It's a power watch sensor, and we've been running 1,300 of them in Ghana for about 4 years to gather longitudinal data on power outages, the start time, the stop time, voltage quality at households and businesses, and then grid frequency deviations too, to look at generation. The actual question is data being key. I mean, I really empathize with the people at the utility company who have a really hard problem where, you know, especially in low voltage outages in Ghana or Kenya or some of the other countries we've worked, you know, you get a call about an outage and you really don't know whether, you know, how big it is, when it started, where to send trucks, how to prioritize it into the face of other outages or against other outages. And, you know, you're looking at your maintenance logs at the end of the year, and it's a little bit difficult to really tightly target which transformers need to be replaced, which feeders are underperforming, which districts are underperforming. So I'm sort of here to advocate for the availability of data. You know, that I think Nline has shown that, you know, you could collect data that was generally cost billions of dollars through smart meter deployments about reliability. You could collect that quickly and inexpensively now. And just generally, I think that we're not unique. There's lots of low-hanging fruit where you could take relatively basic measurements and provide potentially outsized value back into targeting and planning and maintenance. So that's sort of a bit of a scattered introduction to me and I think our beliefs at Nline. But yeah, we're making a stab at that around energy reliability data in particular, but more generally, I think we'd love to see, you know, helping out in problems related to data governance, data sharing across researchers, just generally data getting to the right hands as quickly as possible.
Thanks, Noah. And we will come back to some of those things you mentioned there about, especially about how to deal with the amount of data that might be generated by such devices. But I'd like to hand over to June and ask you, your EEG work involves using satellite data to forecast electricity demand. So it's quite a different type of remote data collection to what Noah described. But you use the satellite data specifically for productive use in agriculture, irrigation. So how does this work in practice? What are you trying to measure, and how would this be expected to help in terms of energy system planning?
Thanks, Ben. I'll start by saying our EEG work has been done at the Systems Towards Infrastructure Monitoring and Analysis Lab at UMass Amherst. And before I just delve into what the work is about, I'll kind of give a brief motivation as to why we're actually doing the work. And so just like Noah, I was at the Sustainable and Energy for All conference, and one of forum in Kigali, and one of the main phrases there was that if it's not profitable, it's not sustainable. And that was with regard to electrification projects. And so sustainable, profitable electrification project is one that can generate sufficient revenue, which outweighs the costs incurred. And one of the key reasons that this is not happening is because of very low demand, which is challenging the cost recovery of this project. And so one of the key ways is to support the productive use of electricity, which then offers this win-win scenario for both the utility or the provider of the electricity services and the customers as well, because then they can actually enjoy the benefits of electrification. So then I move into what we're actually measuring. What we're trying to find out in our work is whether we can find these areas with potentially significant demand for electricity services in the agricultural sector, mainly through irrigation. And these areas can then be targeted for electrification and create this, I would say, anchor demand for electricity services. So in a little more detail is what this involves is then using satellite data like which is publicly available, like pollution data, land cover, elevation models, And we use this to develop a machine learning model that can identify areas with prevalent use of diesel-powered irrigation pumps. And then these can be prioritized for electrification and also provide a more alternative and sustainable source of power for these pumps. And so just to finish up that, this answer is thinking about what the implications of such a model would be then to improve financial viability of electrification projects. So then we can stretch capital budgets and electrify other areas faster. And then we can think about having more cost reflective tariffs that are more affordable to communities. We can unlock opportunities for cross subsidization and also not forgetting cost savings from reduced dependency on fossil fuels.
Great, and a really key question emerging from it, I suppose, and how do people then actually really enjoy those benefits of electrification, as you put it, and use the data, the information you create. Just a quick encouragement to anyone in the audience, do post your questions in the Q&A function. But Anand, in the meantime, handing over to you. You also use satellites in your EEG work, but you focus specifically on remotely measured air pollutants. Now, that work was done at the early stages of the COVID outbreak to help understand the economic impacts of the pandemic on India's economy. It would be great if you could just tell us a bit more about how satellite data on pollution can help us understand underlying economic activity and how much that may tell us about energy use.
Yeah, thanks, Ben. Thanks for inviting me. I'm very happy to be here. Well, I mean, the idea with that work, especially in the context of something like the pandemic, which was a very significant hit to economic activity, is, you know, much of the of air pollution comes from sources that respond quite sensitively to changes in economic activity. So if industry shut down, or if transport reduces, maybe because there are less people going to work or there's less transfer of goods, all of that changes levels of air pollution. We now have more and more data on air pollution in countries like the United States or in Europe. You have a lot of ground monitoring data, so you can use that. But we also now have a lot of satellite data on air pollution, which is pretty well calibrated now to give you a decent measure of ground levels of pollution, and also you can look at changes at a fairly high frequency. And so you can use that to say, okay, when the pandemic hits, how do you see changes in levels of pollution in different cities, and how do you kind of see them rebound after economic activity restarts, and you know, are there differences across places in how quickly they rebound? So you can use air pollution data for that. You can, you know, we've previously had a lot of people, and I've done some of this myself in my work, using satellite data, you know, night lights data to try and track economic activity. Now, that's a more kind of long-term measure. It essentially tracks the rollout of the electricity grid, if you like, because as the grid rolls out and you have, you know, night lights and street lights and so on, that those are parts of the globe that start glowing brighter at night. Pollution is more of a, I'd say, a high frequency response. Yeah.
So before we go into any more of this, I'm wondering, there's a theme clearly here around the frequency of data, and I think with that comes an analytical question of how you handle this amount of data. And June, could you tell us a bit more about the data analysis tools you use, the machine learning methods you employ to use the satellite data?
Yeah, absolutely. So for this work, we're using something called supervised classification technique. So I think the best way to maybe explain this would be by giving a short kind of, I don't know whether it's a story or explanation, but anyway, so we have satellite data, which gives general information about the Earth, either through imagery, so pictures of the Earth, or you can have data like pollution data that Anand is talking about. But we still actually need to interpret this data given the problem we have. And so that's where machine learning comes in. So given as an example of a toddler sees a Japanese spitz for the first time and, well, doesn't know what it is, but you need to teach your toddler what a Japanese spitz is. So you're like, hey, this is a Japanese spitz. It's small, it has white fur, it has pointed ears. And so that's what you use to teach your toddler what a Japanese spitz is. But then you also teach it what it's not, right? By giving it those different characteristics. And so with more and more examples of Japanese spitz, over time, the toddler eventually learns how to differentiate what a Japanese spitz is from other dogs. So our problem here is like identifying the type of the dog breed. For us, it's identifying these areas which have diesel irrigation activity. And then our machine learning model is the toddler. You're teaching it something. But then you need to give examples to your model about what it is you're trying to identify. And so that's where the satellite data comes in, by providing these characteristics that teach our model to learn what it is you're trying to teach it. And so other thing is then you need to have those examples of actually what are those characteristics, and that's where the ground truth data comes in. You are that ground truth data that you're saying, okay, this is where prevalence of diesel irrigation is, and it's not. So we need to have, that's what we call supervised learning, where you actually tell the model what it is, you give examples, and then over time, it learns what it is and it's not, and then you take that model and apply it to areas where you don't have that kind of example data, you don't have those examples. So one thing that then pairing up this remote sensing data, which has a lot of spatial and temporal granularity, does is then we can translate those models to areas where we don't have data and do this at a more granular spatial and temporal resolution, as opposed to traditional data sources that are aggregated either over time, so monthly or annually, and over space at country level. We can be able to then predict at much smaller, spatial resolutions. I don't know if that kind of answers the question about what the methods are, or should I expand some more, Ben?
No, that's great, I think, for now as an overview. And just you mentioned ground truthing, and I think it's just worth saying here that part of your work is using the satellite data, but on top of it, the ground truthing element is to actually go back into the field and conduct interviews, surveys to understand what's really happening. So you are, in a way, using if I understand correctly, a remote sensor methodology, but you go and check how correct this then is.
Yeah.
And I guess that does speak a bit to the reliability of any such data. And I quickly ask you a question, and then I see we've got some questions from the audience, and we'll go to those. But just on this question of sort of data reliability and actually how complex it is. You mentioned the pollution data you've been using is high frequency, which distinguishes it from some of the other measures. So I suppose there's sort of several angles to this question. Is this data sufficiently detailed and reliable? Do satellites actually capture enough information to really draw some conclusions in your experience? And then secondly, what does that mean if you want to analyze it? June mentioned machine learning and other approaches, but what kind of analytical tools do you think you need, both as skills and actually as equipment? How specialized is this?
Yeah, I mean, I think we wonder with any of these data sources, we want to step back and ask when you might want to use them, right? So air pollution is not a good way of tracking economic activity for governments, because they likely have access to much better data that links much more directly to what you're interested in. For example, you might have access to tax receipts, you might have access to electricity consumption from utilities. So you don't necessarily need remote sensed air pollution data to figure out, as a government, as a policymaker, what is happening to economic activity in any area under your jurisdiction, right? In the instance where we were talking about, which is COVID, where you're not collecting any data, you're trying to figure out what lockdowns are doing. That's a special different setting where you're trying to look for clever ways to squeeze water out of a stone, right? So that's kind of one thing to keep in mind. That said, you sometimes might want to know about air pollution itself, which is not measured properly in developing countries. There's very little measurement, and it tends to be focused on a few cities, which then get the majority of sort of policy attention and conversation around them. And so that's someplace where, that's a setting where satellite data can be incredibly useful, and satellite measures of air pollution have are now certainly good enough to make policy decisions, because it, at some level, it doesn't matter whether I have 230 micrograms per meter cube or 275 micrograms per meter cube. It's what I'm interested in are trends. What I'm interested in are comparisons between areas that are heavily polluted and areas that are not. And so that kind of error in differences, rather, between what you might get from a monitor on ground and what you might get from satellite data, are sort of meaningless at some level for policy. In exchange, satellite data gives you, air pollution measures across space and time. So I think it, the same thing with nightlights data, which can be used to extract some information on sort of outages. Again, a government would not need to use this to figure out where their grid is, because they normally know where their grid is. They built it out, those records exist. But they often have terrible data on outages. Now you have, the sort of stuff that NOAA is doing is a much better way of measuring outages than trying to sort of eke it out of satellite data and nightlights data. But if you had nothing else, you might use that as a way of, at the state level, trying to figure something out. I think more broadly, there is a challenge in terms of state capacity to use any of this data in the first place. There's very, very little kind of comfort with using large data sets with just basic statistical analysis. If the quantitative person in a typical government department, at least in the developing countries I worked in, maybe knows how to use Excel. But that's about it. And so then you're in this world where there are data sources you don't understand. There may be academics coming to you and saying, hey, we can use it this way and that way, and they produce some graphs they've pulled out of R or Python or whatever else they're using. You have no way of generating those graphs. So there's only so far that conversation can go. And so I think that's a problem that does need to be solved. And it's only going to be solved when there are tools that are developed for a policy purpose that make it easy to use these data sources. And one set of people that are doing that are private companies. So there's a bunch of startups that have raised money around, and in some ways it's unfortunate, because you're taking satellite data that sort of the taxpayer has paid NASA or the European Union to generate, that is totally free online, that a bunch of graduate students are using in their papers every day. You're doing the same thing, and then you're charging huge amounts of money from people to use that data, simply because that translation isn't happening and someone needs to do it. But I think that's a challenge before we use any of it for policy. And you can, these are just some examples. There are many people trying to do cool things with big data and machine learning, often satellite data, all of which I think to the policymaker are too much of a black box to really use. Because remember, if you make policy around something, I also need to justify it. I need to get into arguments with the media, get into arguments with people. I need to understand what my data means or doesn't mean. So, that's something.
Yeah, Anand, thanks so much. And I think this issue of how you build capacity, we absolutely want to come back to, but I think there have been a number of questions. So Simon, if I hand over to you for what our audience has been asking.
Okay, we've got 5 questions so far, 3 posted just now, and then 2 were actually provided when people registered. So maybe I'll start with one for Noah, which is essentially how useful is your data for utilities? What exactly does the sensor measure, and is the device affordable?
Yeah, so those are all great questions. How useful is the data? So again, the data that we're collecting is from sensors that are plugged in at households and businesses. So all the way down at the very edge of the grid. So oftentimes when a utility builds out any automated metering, they'll start at sort of the highest voltage lines. There's fewer measurement points and it drives the bottom line a little bit more. And then SCADA will sort of expand down to the medium voltage, and then if there's budget for smart metering or other low voltage automated metering, that will sort of be added at the end. So in that system, there hasn't been a lot of good examples of utility companies around the world actually having access to very high quality low voltage automated measurements. So oftentimes the data is coming in from the customer call center, but obviously there's sampling issues with that. People are less likely to call at 4 in the morning, or less likely to call when the energy is historically unstable, and there might be less faith that a call would actually lead to action. So in terms of the actual data then that we have that's a little bit different is we have the duration of outages that are actually happening. We have it time-stamped to the second. And then we also have those outages counted really at the low voltage. So we could say, and in one of the countries we're seeing, many, almost 150 times more low voltage outages than the utility is able to get from their capture. So again, this sounds like big data. This sounds, I think, like smart meters and everything, get people talking about meter management systems or sort of siloed, complicated systems to interact with from the SCADA world. Over our 4 or so years of operating in 6 countries at maybe 2,500-ish sensors, we've generated a little bit more than 1 billion data points. So it's a fair amount of data, and we've built a lot of systems to sort of deal with that, but it's not so much data that we're talking about needing many clusters of specialized cloud servers to process. I think a big thing is we've made a lot of engineering decisions to really focus on simple significant signals as opposed to really high frequency sort of data dumps of kilohertz lines of voltage traces that no one really knows how to deal with. So we've been able to subsample a fair amount from initially. And sorry, I don't know if are they low cost? Yeah, so we could measure like a whole country for order of millions of dollars, small numbers of millions, where that would be order billions off historically in smart meter. As Simon looks away, but we could talk about the numbers a little bit, but I do think that we're less expensive. And again, whether Enline's doing it or anyone else is doing it, I think that the overall message is just that this data is within the realm of affordability. So, I mean, we really benefited from our EEG funding. We were also funded from MCC and their local implementer, MITA in Ghana. And we took, a small number of millions of dollars from their monitoring evaluation budget, and were able to get there quickly, instrument a large part of the grid, get data back, and hand it off to policymakers like agilely. And like, it's not this like big messy corporate process that has to go through before the data is available. So again, that's really the point I want to continue driving home. Our data, we could look at things like differences in service reliability across demographic characteristics within a district now. You could actually really drive down into, the fairness and equity of service. We could look into a lot of these higher frequency, almost economic questions that you need higher frequency data to support. And I just want to add real quick, we just published a paper with June's lab. June wasn't on it, but Zeal, Shah, and Jay Taneja, that was actually fusing the PowerWatch, GridWatch data that we've collected in Ghana with satellite nightlight data to actually train that data on direct ground truth, higher frequency measurements. And we're showing that we could actually really improve the predictive power of a nightlight's sort of energy stability estimator with the presence of these sort of on the ground in the households and businesses sensors that are connecting, every 2 minutes they're sending us data.
Brilliant, thanks Noah. That was a really comprehensive answer. Go on to a question for June, maybe, which I think you kind of answered, but you might want to add a bit more to anyway. So it's for agricultural energy demand, what type of data is collected and how do you consider the baseline, since in rural areas energy access is too low? I mean, my understanding is that you're not actually collecting energy demand, you're checking whether or not diesel pump sets are present, and with the intention of then seeing the potential for electrification of those. So, and I guess you're not also then therefore looking at irrigation potential only where that irrigation potential is already realized, is it?
Absolutely. And maybe one thing I can add on that is this part of the work was also, I would say, a build upon or augmentation of work done by the QCell lab at Columbia, which also looked at irrigation prediction, or where there could be demand for, irrigation or irrigation pumps. So I think this would be an extension of that work. It has been done before, and there's also work that has been done looking at agro-processing load for agricultural demand. So yes, I would definitely stress what Simon has said. We're looking at areas where there is agricultural activity, but then what could electricity services be used for in this area? So we're trying to harness that, what we call latent electricity demand.
Brilliant, thanks Jude. A question for all three presenters from Noel Hines in Arizona State University, and that's sort of the question is what transformations in the social energy system are anticipated with the use of these technologies? How is vulnerability considered? I mean, I guess we're slightly rephrasing that is, can any of you imagine ways in which you might use these remote sensing technologies to look at issues of vulnerability or the sort of social side of energy systems?
Mind if I jump in?
Go for it now.
Yeah, so it's a really good question, and it brings to mind two things. One of them is around the role that regulators play in energy systems and their need for independent sources of data. So I think one of the things that we've encountered is, again, broadly, the people I've met in the energy systems in the countries I've worked with have all really cared about providing better quality service is the frequent thread. The frequent complaint from the regulator is, well, we're really just tied to whatever data on reliability that the utility decides to release whenever they decide to release it. And then we just have to sort of sign off on that and regulate based on that as ground truth, when, sort of popular culture and just the regulators' personal lived experiences is showing, that the overall system is less reliable. So whether, again, whatever the source of data is, being able to provide that data from an independent perspective, either for the regulators or for researchers as well, I think is a hugely sort of under-leveraged space for driving policy. And then really quickly, I could stop there, let other people weigh in, sorry.
Okay, June or Anand?
Yeah, I could also go maybe add on a little bit. In addition, is also thinking about how this was, I could maybe reference a few previous work that has been done, maybe thinking about inequities in the pace or quality of electrification, thinking about, you know, when we're thinking about these targeted programs, are they exacerbating any kind of inequities or injustices? So that is some of the work that has been done there. But I would also highlight the other side of the coin of thinking about how we evaluate our models and how we consider the equity implications of the models we use as well. So I think that's something that we probably need to do a little bit of more work on, as well as also in addition to considering using the tools to bring out those vulnerabilities and inequities, but also thinking about how our tools could actually exacerbate them.
Cool, thank you. Anand, do you have anything on that one? Otherwise, I'll move on to the next question.
No, I think that summarizes most of it.
Okay. So the next question is also to all three of you. So maybe Anand, you can start with this one. And it's data is only useful if it's used. Is demand generation at all a part of your work? Have you had to create awareness and demand for data and associated insights that your team is producing? Or another way is, this question has been put, is what types of customers have already been using your data for decision making?
Yeah, I think I tend to work with electricity data and data on air pollution. With the data on air pollution, we've definitely been trying for a while to have greater use of satellite data as as a means of reporting and talking about pollution and determining which areas need more attention. Given that ground monitoring of pollution using sort of the regulatory standard air pollution monitors is very expensive, and they aren't very dense on the ground in places like India. That's been it's a source of data that the media that government officials and policymakers in general are quite open to using and having a conversation around. I have found that regulators much less so. I think there are multiple reasons for that. One is just they're conservative. It's often engineers who are very aware of how these monitors work and have spent a huge amount of their time thinking about calibration and error rates and so on, and are therefore at some level, I think, uncomfortable with the idea that some of those things don't really matter for policy. A noisy signal that captures trends and levels is all you need for policy, and it's hard to wrap your head around that when you've spent tons of time thinking about how this $50,000 device accurately measures pollution in the specific place it's in. So we've had more of a challenge getting sort of regulators to put that data up and use it. The environmental regulator is a core part of their decision making. But more and more sort of pollution policy is made by many departments, and people are willing to think of it. In the case of electricity, I think the situation is a little different. So utilities have a lot of data. They have a lot of metering data, they have a lot of billing data, collections data, and so on. What they don't have is the ability to use that data very well, which gets back to the capacity problem I was talking about. So what we've done there is work with them to ask questions like, you have all these variables on millions of consumers. Sort of, what can machine learning methods tell you about, say, how best to target different enforcement actions to different types of consumers to increase the bill payments that they get? Or how would you use your smart meter data to infer where there's theft or there's not theft? And that's something that they're very open to. I think there's still this elephant in the room problem, which is they don't necessarily have the skills to do it themselves. And you can't have like large scale public policy being conducted on the off chance that you happen to come in contact with some academics. So that's a problem, but there's definitely openness to using those methods and willingness to, I think, because the raw data is something they collect. So they understand what data is being used. I think it's more challenging when the data source is not something that they have any visibility or comfort with.
Great, thanks. That's useful. Noah, did you want to come in on that?
Yeah, maybe. So I would maybe supplement the statement of data is only useful if it's being used with like, well, at least with the likelihood, I think, of data being used is also tied again to like the trust in the data quality and the sort of closeness to the sample to the underlying problem that the sample is being used to address. So for example, like we were doing some work in West Kenya that was comparing construction quality standards against, this is also, I believe, with EEG, comparing construction quality standards against two different villages that had been recently electrified. And there, really, like, the data usability, a big feature of that was like, could we actually get data, before electrification happened and after, and like, can you actually be agile enough to be there to collect the data that is needed for the problem. So I think that, again, moving away from like sort of the smart meter, really static, expensive way of taking measurements, or even $50,000. I know that those exist in air quality, but those certainly exist in voltage measurements too. Like that class of everyone takes it out with fancy gloves on type sensor, to something that's a little bit more agile and I think a little bit more dynamic, especially as grids start failing, with a new climate situation and everything else. I think is an important paradigm shift that is really related to usability. If the data is as dynamic and available as systems are changing, then that data is going to continue to be valuable in the presence of that change. Yeah.
Yeah, and your meters were very agile, weren't they? I mean, you redeployed them three times in a matter of months.
But and so is satellite imagery, of course, which is Planet Labs is imaging the Earth every day. There's plenty of other publicly available sources, and June and Anand have obviously been able to extract some real value from that data for us. So again, I don't think that there's any competition between sensors at houses and sensors at the Earth. I think that there's just sort of different application spaces.
I'd like to go on to one topic that Anand has mentioned a few times, which is sort of how accessible is that data then really to government? And without wanting to put you on the sort of uncomfortable position now, but I think there's this challenge. I suppose you're right in saying regulatory capture is a big issue. You need to have access to independent data. But likewise, as Anand was saying, you can't sort of rely on academics providing that information. Yet is the solution here really that it's a private company that provides this high frequency data, be it in the form of grid watch sensors or other forms, or what's the how accessible, for example, in the case of your data, is this information really to not just the utility or the entity that may commission it, but indeed the policymakers, the wider sphere?
Sorry. It's something that's changed even over the course of the EEG grant that we had then, where initially we set out to, again, our data has been roughly the same quality. We've been improving it with sort of data cleaning algorithms, but for a number of years now. So the problem that we've really been focused on is actually both maintaining deployments of large sensors, but also sharing data back with policymakers. And we spun up our own custom visualization thing, and it was expensive, and we sort of let it die, honestly, in favor for a new tool called Grafana, but which provides sort of really quick and easy time series graphs that could all be configured based on the KPIs of the stakeholders, and everyone could just access it and download it and whatever. And I think that like there are open source projects like Grafana and a lot of stuff out of Apache that will sort of over time solve some of these, like the actual technical data governance tools, or like if you want to build up a nice visualization, I think anyone could sort of do that with an undergrad degree and a couple of weeks of motivation now. But in terms of broader data extraction from governments and utilities, I sort of feel like that's above my pay grade, above maybe all of our, like that sort of feels like that has to come from a player like World Bank or IMF, or someone who is going to really be able to put some global pressure on these countries to put that data in some repository. I mean, in the individual countries that we've worked, every stakeholder we've met has been incredibly receptive with sharing data, and just knocking on doors and explaining why the data is valuable for the project has worked really well. But you're right, that certainly doesn't scale globally.
That's an EEG program. One of the things we run is this as a roundtable on energy planning. One of its core principles is national ownership and access to that data, so that these kind of analytical efforts don't just reside in the ivory academic towers, but actually benefit people within those countries. But Anand, I think sort of you also run a different EEG program which looks at the deployment of smart meters, and I think it's interesting hearing Noah's story here about the opportunity for deploying small scale sensors, when my understanding with your project in Haryana, India, is that it's been rather difficult to get these smart meters installed and then used. I mean, so there's sort of two parts. What are the benefits of those smart meters as opposed to maybe some other sensor, if it's true they're quicker to install, but then also is that data really being used if the installation of smart meters is so difficult?
Yeah, I think so. The problem in India has not been installing smart meters. India is spending billions of dollars installing smart meters, and for the most part, utilities have been able to put them in, and there are tens of millions of smart meters now in India, and it's rising every day. The challenge we had in our project was in actually using that, and I think that's an important question with technology, whether it's cheap and low cost or whether it's much more expensive, and like a smart meter. Now, a smart meter allows you to do many more things than something that just measures outages. So you are getting more for your money as well. The question of whether it's the question of whether buying the tech means that you're going to use its capabilities is, however, important. What we have been finding in India is that it's not necessarily the case that utilities or politicians want to, for example, remotely disconnect people or put them on time of day tariffs or put them on, prepaid meters or any of those things that are what you're paying for when you install a smart meter. And so this is an example of a much advocated for infrastructure investment that governments can make. I mean, different developing countries are in different places with regards to how much money they have. Countries like India certainly have the money to install them, but that doesn't necessarily mean that they get used. And so, one view is that if you build it, they will come and, let's collect all the data we can and let's put in place all the infrastructure we can. And once we do, we'll figure out, you'll gradually get to using it. I'm not so sure. I mean, I'm a little more skeptical of that way of thinking about it. It spends a lot of money upfront, and it has, sometimes you discover that the kind of data you want isn't what you're actually collecting because you didn't really think of the use case before you started generating data sets. And so there's a risk of that kind of thing happening. So with smart meters, I think that was the problem. It was more and it's therefore going to be different in different state governments and different settings. Hopefully, some of them will use these features and demonstrate that they work well, and then it will get carried on from there. But right now, it's just about buying the hardware. And so one thing we're trying to do, for example, is to show that you could use that data, for example, to detect where theft is happening. But again, it's not obvious that the reason theft happens is because you have absolutely no idea where theft is occurring. You may not have a sort of precise number, but it's widespread and it's rampant. And so if you're not seeing policy that is strongly aimed at clamping down on that, then it's unlikely that getting sort of a quantified measure is going to automatically turn into that.
Thanks, Anand. Simon, is there another question, or are there several other questions from the audience? I think we've got time for.
Anand just answered one of them, which was on whether smart meters can be used for looking at energy theft. But I think there's another one from South Africa, from the National Energy Regulator's office there, asking more about sort of smart meter data, and it's, are there examples of it being used for demand side planning as opposed to just sort of billing or monitoring? So I guess that's an and question mainly, but. So the question, Anand, was are you aware of examples of sophisticated smart meter data being used for demand side planning?
Oh, I mean, they've definitely been used for demand side management. If the question is, are they being used for that right now in India, which is where I am most familiar with the applications, then the answer to that is currently no, but I think that will happen with commercial consumers fairly soon. There's a bunch of utilities trying to push for that and so on. And I know they've of course been used for that in the West. I think they've also been used for that purpose in parts of Africa.
Okay. I mean, maybe just to extend that question or to reword it slightly for June, just and maybe going back to the sort of question about data usage again. I mean, do you have an audience for your data in Ethiopia? Is it being utilized in planning?
So I probably can answer that question definitively. All I can say is we've been engaging with like the ministry and stakeholders there and giving visibility to the kind of work we're doing, either through webinars, through reports, but in the sense of it being picked up and actually being used, I probably can answer that. And I think just as academics, that's usually the aim of our work is do all this work, create policy recommendation and actionable items, and then find a good way to disseminate our data and kind of target the appropriate stakeholders and give visibility to our work in the hope that it can actually be used to guide policy planning. But I think that's, as far as going beyond that into implementation, that's probably beyond the scope of the work.
And yet it speaks to the kind of continuous engagement, I suppose, of research and policy and utilities to really make the full use of the insights that are being generated and to some extent ensure the longevity of some of those tools. We are reaching the end of this webinar, but I think one closing question I would like to ask about to each of you is about the need for further research, but I would be specifically interested in your view of what do you think are the big research questions that you feel need to be answered around the opportunities for remote sensors and technology to actually help energy planning. So for research, for remote sensors, a bit like Anand was touching on earlier, not just to be a piece of information out there, but what would make the difference to help energy system planning?
I could
start with Anand. Yeah, you you volunteered yourself.
No. I was going to say, Ben, your voice cut off, so I didn't hear that last bit. So maybe we should start with someone else if they heard the full question. You were very clear.
Yeah, I'm happy to kick it off here. So, I mean, again, in much of the world, what's actually happening on the grid is relatively unknown, especially at the low voltage levels. And without really a picture of what's going on, it's really difficult to make the right decisions as they relate to either policy or investments or day-to-day operations, or sort of, again, empathizing back with the network manager who has limited resources to make improvements to reliability, and then also doesn't really know where those improvements need to be made. So for me, that feels like, when we were in a situation where me and Josh, my PhD collaborator, and Susanna and a couple of us, when we were in a position of being able to design a sensor, deploy that sensor at scale, and become source of like a major source of ground truth data on the performance of a major electric system in Accra, Ghana, and to the point where we were ground truth data for a $500 million MCC compact. That feels like there's low-hanging fruit as a researcher. With better data, I think that we can have better impacts at lower costs, which is particularly valuable, I think, in the developing world, where resources are spread a little bit more thin. And I think traditionally having all of this data tied to either expensive sensors or being held by a utility, which even if they have data, there's all sorts of reasons why a utility would be slow to share it. Moving beyond that to where data is actually freely shared, and researchers can look at the overall sort of energy systems in these areas that have previously been really opaque. It seems like there's just a tremendous amount of value in that across all of the different areas that we're talking about here today.
And great. I was just going to add a little bit on what Noah said, because it said a lot more of what I wanted to say, but also thinking about how we create scalable and transferable models, because the intention of using all these remote sensing data and machine learning models is to then bridge those data gaps, the data gaps in different areas. So I know this will speak a lot to what Noah said with data, figuring out how to leverage other digital technologies, like the remote monitoring, crowdsourcing, to actually have those better ground truthing, data collection methods, and then create much more broader impact for the work.
Yeah, I think the transparency aspect is valuable because there are many kind of voices that influence policy. And so, if you want to influence environmental policy, it's not just environmental regulators who matter, it's also politicians and people and what they see, and that comes from transparent data. Likewise with energy systems. So I certainly think there's a huge role, and that can be served by academics or nonprofits by putting out products that and tools that people can use. And I think that generates that can shift policy through public pressure. I think integrating it into decision making will ultimately require, there's one of two routes. One is capacity building, the other is private companies turning these into products that are sold. And the reason is that, whether that model at least provides a product that is updated, that I'm paying money for, therefore there's certain accountability on it, and that other people can buy and check and debate and so on, which is not the case when sort of academics work on one-off projects with people. So it's possibly the case that if we don't have that capacity built up within government, then one way in which that might happen, and certainly there appears to be venture capital funding betting that this will be the case, is that private companies could do that work and then make products and services available to governments who could then buy them. And that's another model that I could see happening.
And the thing to add to that, hopefully, is that the ingenuity, the motivation of you researchers such as yourself and others will drive this forward, seek new opportunities for continuing the research and new opportunities for funding. And it is a shame that the EEG program is drawing to an end, and we can't do much more of this, but we would love to see these projects live on. We would love to see engagement with policymakers continue, because I think what you touched on here are some real opportunities for data, higher frequency data collected in ways that may just not be accessible, avoiding some of the regulatory capture, enhancing transparency, are real opportunities, but they do come with the challenges of having the necessity to be able to access this data, interpret it, utilize it efficiently within the planning. So I found this webinar really enjoyable, and I'm extremely grateful for your insights. I hope everyone else found it interesting too. We'd be grateful if you continue the conversation offline and completed a short survey at the end to help us learn from these webinars as we run more of them in the future. So thank you very much for this. That's all we have time for today. Have a good rest of the day, evening, wherever you are. Many thanks.
Thank you. Thank you.
Thank you, Ben. Thank you, Simon.
Bye.